All right, good morning. Today we're going to be talking about transformations. You should have some familiarity with these. Not sure how much you remember, but let's talk about them today. The first transformation that we're going to talk about is a translation. And a translation is nothing more than a slide. So let's look at these and discuss what kinds of translations they are. The first one here we have, it's a translation where the red figure is moved 3 units up and 2 units to the left of the blue figure. And if you will note on the red figure, those letters have a little prime mark out beside them. It looks like an apostrophe. So that those would be on the blue figure, you have um, the R, and then on the red figure, you would have R with that little apostrophe, and that's read R prime. All right, let's look at the next one. This will be the box, the gifts over there. And so when we look at those, this one, it's not on a coordinate grid, so we can't translate count the units of the translation. So this is just a translation down and left. And if you see the arrows there indicate which way that transformation occurred. And if we look at the next figure, we have a translation down and right. And again, on this one, we don't have arrows to indicate the direction, but we have A, B, C, and then A prime, B prime, and C prime. And the translation or the translated figure is always the one with the primes on it. And then if you look at our last figure there, we have a vector indicating how the translation has gone. And here the translation went up and right. Now, later we will do more translations on the coordinate grid, but this is just to give you a basic idea or a reminder of what a translation is. All right, the next transformation we'll talk about will be a reflection or a flip. And if we look at the first one, we need to, when a reflection, you always have a line of reflection. And so there is our line of reflection. And then, even though that line is vertical, if you look at the dots that are matching the reflected points up with each other, if you'll notice, the line of reflection is perpendicular to the segment connecting those points. And then the segments connecting those points are horizontal. So that's what makes this a horizontal reflection. And it's like we flipped it across that line of reflection. If we folded that figure across the line of reflection, those points would lay on top of each other. So each one of those points is the same distance from the line of reflection. And if you look at the next figure there, again, we identify our line of reflection. And then if we connect the points of the image and the reflection, then these lines are vertical. And notice those lines are also parallel to each other and perpendicular to the line of reflection. And this is called a vertical reflection, where you're flipping either up or down. Now, on the other side, we've put these reflections in the coordinate plane. And for the first one, we are reflecting that across the x-axis. That is a reflection across the x-axis. And we notice that we have the ABC and then the A prime, B prime, and C prime to show us which one our reflection is. And if you counted those points, they're the same distance from the x-axis. C and C prime are the same distance, B and B prime, and then A and A prime. And of course, here we've labeled the coordinates, and you may notice some things about those also. Looking at the other reflection down there, it is a reflection across the y-axis. And again, if you notice, B and B prime are the same distance from the y-axis. A and A prime are the same distance from the y-axis. And C and C prime are the same distance from the y-axis. The y-axis here is serving as our line of reflection, just as in the previous one, the x-axis served as our line of reflection. All right. Now let's look at a rotation. A rotation is nothing more than a turn, and it can go clockwise or counterclockwise, depending on which way you turn a figure. And so here, let's look at this first one. If you see, we have A, B, C, and then A prime, B prime, and C prime. Here we have an angle indicating how far we have turned it. In this case, it's 90 degrees. And this went the opposite of the hands of a clock. So this would be a counterclockwise 90-degree rotation. All right, because it moved backwards for the hands of a clock. And then if we look at our next one, You have A on one of those figures and A prime on the other, the one that looks like a little rocket ship. And if we see there, that is a clockwise rotation. We don't have a degree measure. If we had a protractor, we could pull it out and measure it. But we do know that it is a clockwise rotation because it moved in the direction of the hands of the clock. And then if you look at the triangle down there on the bottom left, we have an arrow indicating how it was turned. We have no primes or anything like that. But this one was also a clockwise rotation because these arrows moving in the way that the hands of the clock would have moved. And then in the very last figure, we have something is on the coordinate plane, and it's indicating to us how many degrees it has moved. And it went 180-degree rotation. If you rotate something 180 degrees, does not matter if you're going clockwise or counterclockwise, you're going to end up in the same place. And if you notice, 180-degree rotation actually turns that figure upside down. As a matter of fact, when you move these, when you rotate them, the figures are definitely oriented differently. So that's something to remember when you see one of these and they're all jumbled together, reflections, rotations, translations, and you're trying to remember which one is which. Just remember that a rotation is always going to be turned in some way. And here we have dilations. You can, where we have either enlarged something or shrunk something. So pre-image and image are another way to denote what you started with. So the pre-image is what you begin with, looking at the little penguins there. And then the image is showing what happened to it. And in this case, this was a shrink. Okay, that image got smaller. And then on the next one, the map of the United States there, the pre-image is small, the image is larger. So this was an enlargement. And then on the triangles that are on the coordinate grid there, if you notice, those have the primes on them, and it's also an enlargement. The red triangle is larger than the black triangle there. And probably on your printed paper, you can't tell that, but the one with the primes is larger than the one without the primes. And then on the last figure, if you notice, you have ABC and then A prime, B prime, C prime. It's not on a coordinate grid, but it is showing you the point that it was and that is a shrink because the one with the primes is smaller than the original. All right, and dilations usually are enlarged or shrunk by a certain factor. Here, we did not really give the factor. The coordinate grid is the only one that we could determine that factor on, and I believe it was 2. I believe if you look at those coordinates, you'll see that they're all twice as large as they were before. But it doesn't necessarily have to, we don't necessarily have to know what the factor is. So we can tell by looking at it whether it got larger or got smaller. And now let's sum up these things that we've talked about with transformations. First of all, a translation is a slide that creates figures that are the same size, shape, and orientation. Then a reflection is a flip that creates figures that are the same size and shape, and it changes the orientation. A rotation is a turn, and it creates figures that are the same size and shape. It also changes orientation. And their orientation, guys, just means how it is situated in the plane. Like if A was at the top and B was at the bottom and C was over to the right on the triangle, then if I reflected it, it's going to change that. Or if I rotated it, it's going to change that position. And if you'll look back at the rotations and reflections, you will see that their positions are changed. And a dilation is an enlargement or a shrink. It creates figures that have the same shape but different sizes. And let's look at one more thing about these transformations. Let's look at whether they are similar or congruent. And first we need to talk about similar and congruent. So similar figures have the same size and congruent figures have the same size and the same shape. Again, congruent figures are the ones that have the same size and the same shape. If you will think about the transformations that we just talked about, which ones kept the same size and the same shape? Then similar figures have the same shape but not the same size. All right, and as I talked about earlier, similar figures are similar by a scale factor. And then congruence when you have the same size and the same shape, that is just a special case of similarity or of similar figures. And in that case, the scale factor is equal to 1. So let's look at the transformations that we've done and decide whether they are similar or congruent. So let's think about a translation. Did it preserve the size and the shape? I hope you answered yes, because a translation creates congruent figures. And then a reflection. Does a reflection preserve the size and the shape? And again, the answer should be yes. And reflections create congruent figures. And a rotation, does it preserve the size and the shape? And yes, rotations create congruent figures. And then similar, our dilations create figures that have the same shape. A triangle still looks like a triangle, but it's either going to get smaller or larger. All right, so I hope that clears some things up for you and that you do well with this unit.